Okay, so we just left off in the last video talking about Pareto improvements with the Edgeworth box. We walked through a simple example of an allocation at point E, and we talked about a Pareto improvement, point F. What we're going to do next is take this a little bit further. We're going to think about points, allocations on the Edgeworth box that have no Pareto improvements. Essentially, when this lens, this pink section, is completely gone. So we're going to jump down, we're going to start this graph all new. And we're going to think about what must be true. What must be true for the allocations to be completely gone? I drew this backwards. Okay, so we had Andrew's 0, Bea's 0. We had a x, a y increasing on the vertical. We had by decreasing on the vertical. We had a x increasing on the horizontal, and we had bx decreasing on the horizontal. Okay. So jumping back to this graph here, we can see whenever there's a lens, this pink region, we have a Pareto improvement. So the lens represents the whole set of Pareto improvements. What we want is a point where there is no lens. This point happens exactly at the point where the indifference curves are tangent. So we'll call this E star. And this is the point where there are no Pareto improvements. And this happens when the marginal rate of substitution for Andrew is equal to the marginal rate of substitution for Bea. I'm just going to let this sit for just a second. Essentially, all we've done here is look at the indifference curves. We've tried to find allocations that improve both Andrew and Bea. And we found that we can always find a Pareto improvement when the marginal rate of substitution is not equal between the two. Okay. Another way of thinking about this is going back to our original graph in the barter economy. Andrew and Bea have an allocation E, and they're willing to trade. They're willing to trade some for the other. So they identify the fact that they can move into this lens and end up better. So they're willing to trade at a rate equal to the slope of this line. And they end up at point F. And this point F makes them both better. Okay, so we barter and trade, which leads us towards a point like this, where the marginal rate of substitution is equal between the two. So this is nice. But we also know that changing the original endowment shouldn't affect our result here, our marginal rate of substitution between the two. If we had adjusted our original endowment, we had given more to Andrew in both of these, we would have ended up with a higher indifference curve for Andrew. So we have something that looks like this. And we could have walked through and found an indifference curve for Bea, and found a lens, and found a higher point of tangency between the indifference curves for the two, and a higher point of tangency for Andrew, because this would have meant a lower point of tangency for Bea. So what this means, we're going to do this cleanly on the graph down here, or I should say more cleanly, is to a point of tangency if we had shifted to a different initial endowment and walked through finding the allocations, in the points of tangency, we could find the whole set of Pareto efficient allocations. You'll see they depend on the original endowment, which determines the original indifference curves and what the lens looks like originally. So the Pareto efficient allocation depends on the original endowment. And what this means is, depending on the original endowment, we can find a whole range of Pareto efficient allocations. And this line, maybe do it in pink here, or purple, depending on your eyesight. This line here is what we call the contract curve. And this is the set of all Pareto efficient allocations. Okay, so this is pretty cool. Okay, great. So we've set everything up. We found the set of Pareto efficient allocations, which happen when the marginal rate of transformation between the two is equal. At this point, you should recognize how you would solve this type of problem, where you define the contract curve. You have all the tools in your tool belt to be able to do this. The next thing, when we're thinking about prices, right? Is the price right? That's the question. Is the price right? Look at me, I'm cracking myself up, writing on a computer screen by myself. The question is, where are prices coming from? And maybe in the back of your mind, you have sort of a tickling that what we're doing next is introducing prices and talking about a price line. Okay. And the next, what we call this, is competitive exchange. So this is really where we try to pin down prices. So I'm going to keep the same graph here, but what we're going to do is think about where prices might come from. So for prices to be set properly, we need to make sure that neither Andrew or Bea would be willing to do something different based on the prices and their current indifference curve. So we're at this point here in the middle, and we want to find prices where neither Andrew or Bea is willing to trade at these prices, would be willing to sell some and pick up some more of the other. Another way of thinking about this is asking, at what point, at what prices does this point, E star, solve both Bea's consumer's problem and Andrew's consumer's problem? That's the question here. Mathematically, the answer here is not that complicated. We want to solve for prices. We want prices that solve Andrew's problem and Bea's problem. Andrew's problem is solved where MRS is equal to the ratio of prices. So price X over price Y. And for Bea, her problem is solved with a similar relationship here. So mathematically, we know these are all equal. We've set the two marginal rates of substitution together, which gives us prices. And let's not forget the negative. And this is the solution. This is the solution mathematically. Graphically, we want, thinking back to our consumer's problem, we want a budget, a price line that runs tangent to both of the indifference curves simultaneously. So essentially, the budget line runs right through the middle, like this. And the slope of this line is px, py, and it runs through our endowment. And that's competitive exchange. And what we've shown here, because we know this solves Andrew's consumer's problem and Bea's consumer's problem, we've found prices that do it for both. And we've shown that this point is Pareto efficient, given some initial endowment. Okay, so this is the high level. We're going to take a step into production and efficiency. In demos coming up and in your homework, we're going to actually walk through and solve these types of problems, these Edgeworth boxes. But the idea here is just to set up the intuition. So if you have more questions, feel free to email me about this. This is deeply important to economics, this competitive exchange. Take a look at the textbook for more details if you need. Okay, so the next thing we're going to talk about is the production possibility frontier. So we can think about this also as production. And for the moment, I'm going to abstract away from where the PPF is coming from. There are more details in the textbook. I would highly recommend looking at them. But let's say we have a production possibility frontier. And we have a point on the PPF. The production possibility frontier is bowed outward. And we have a point on the production possibility frontier. Let's draw these as thick lines. So on the vertical axis, we have y. On the horizontal axis, we have x. And we have our upper bounds, what should we call this? X bar and y bar. So this is how much we're choosing to produce as a society. And movements along the production possibility frontier represent trade-offs. So we trade off some X for some Y to gain more of the other. So you've seen this before in your intro class. But it turns out this Y and this X, along with the origin, give us an Edgeworth box. So when we move up, we can think about this origin as Andrew's zero allocation. When we move up, we increase a y, and when we move out, we increase a x. And we can think about this point as Bea's origin. When we move in, we increase Bea's x, and when we move down, we increase Bea's y. So this becomes the space for the Edgeworth box. Which gives us our Pareto efficient point, given some initial allocation. It gives us the price line, we also have this trade-off between X and Y on the production possibility frontier. And it just so happens that this trade-off at a societal level, we want to make the trade-off equal to the price line, which solves the firm's problem. And I'm going to stay general here. We're not going to dive too deeply into the firm's problem and how it relates to the production possibility frontier. But in the background, firms are choosing how much of each to produce. And that trade-off is represented by the production possibility frontier. And that trade-off for the firm is represented or is solved using prices. The prices faced by the firm must be the same as the prices faced by the consumers. And that's captured by the slope. So the general equilibrium solution happens when these prices are parallel. When firms face the same prices, optimize, and produce as the consumers who are facing the same prices, optimizing, and consuming. And this is our general equilibrium. Okay. So just to close out here, we have two welfare theorems. One, the first welfare theorem of economics. Every competitive equilibrium is Pareto efficient. And we've shown this, graphically at least, that there is no Pareto improvement. We can't move from this point and make everyone better off. And we can't even move from that point making some people better off without hurting others. And the second welfare theorem I can't write. For any Pareto efficient endowment, for any Pareto efficient allocation, there's a redistribution that allows us to achieve it. A reallocation that allows us to achieve it. Said another way, whatever our endowment is, we can reallocate and achieve any Pareto efficient allocation. This second welfare theorem is defined in a lot of different ways. So take a look at the textbook if the intuition here isn't exactly clear. But essentially all we're saying is, if we go back up to our original general equilibrium graph, we can just change the endowments here and redistribute from Andrew to Bea in a way that allows us to achieve any point on the contract curve. Okay. So this is a lot. It's also very profound in my mind. So what we're going to do next is walk through some examples. So those will be coming in the next videos. Okay.